get back to the original problem. So we know that we're to find the v0, L, and t. What we have is the change in y, and we have the final velocity. What we also know about velocity is the unit vector, which came from theta. So, from these, going to velocity, length, and time, what do we know and what can we solve for? Well, the last equation that we just came up with was a velocity with respect to the y position. And we know a lot about velocity, everything but the initial magnitude, because this is magnitude, we know the direction. And we have the change in y. So we'll use all of this information in this equation to solve for the initial magnitude of velocity. And I'll rewrite that equation down here so we don't have to look at it from earlier. And that's negative 2g y of f minus y naught. This is 0. We've defined that looking at the apex of the arc. And this is two unknowns, and we know one of them. We know sine of 60. This is 32.2. Make sure you know which metric system you're using, if you're using metric or if you're using English. And this is 200 feet, and we've defined this to start at 0. And when you solve for the one unknown that we have here, v0, you'll find that it equals 131.0 feet per second. So we have now our initial magnitude. And let's move on and see what we need to solve for next. We now have the change in velocity, the change in y, and we're looking for the change in L and the change in time. The easiest thing to go to next is looking at the change in time. Whenever you have an easy way to solve for time, it's a good idea to do it, especially if you're given values in time or if you're looking for values in time at the end of the problem. And we have a v of t, y, and we have a y of t. So in this case, we have enough to solve for it using the velocity equation, or we could solve for it using the position equation. I chose to use the position equation, but you can do whatever you want to do as long as you have enough of the knowns. First, we'll look at t naught to t middle, which is the random point on the arc that we have to solve for. And that uses y middle equals y naught plus v naught time minus 1/2 g tm squared. And plugging in the values that we know, 131.0 sine of 60 times time middle minus 1/2 32.2 times middle squared. And solving for t middle, you'll find that it equals 1.948 seconds. And doing the same thing to t final, you'll plug in the values that you know. 131 sine of 60 times t final minus 1/2 of 32.2 t final squared. So the only difference between these two values is the f instead of the m, and because of that we're using the different y values. And t final equals 3.52 seconds. So now we solve for the time at both of those positions, which is helpful because when you move on and you look for the change in y, you have the change in v, you have the change in time, and now you're looking for the change in L. Before we leave time, though, I do want to mention that you get two values for the solution because you have a squared. Sometimes it's very clear it's a positive value of time and a negative value of time, so you obviously know that use the positive value. If you're having trouble choosing which of the values to use and which of the ones that make sense, let me know. I may need to make a separate video for that, but usually it's fairly straightforward, so I'll just leave it at that right now to make sure you know that you choose the one that makes the most sense. Okay, so which equation are we going to use now? There's a few that we can choose from, but the ones that we've derived today, the one that makes the most sense and the one that we can use is L with respect to time. And I'll write that down so that we're using that there, so that you don't have to reference it from earlier. Lm equals L naught plus V x naught Tm. This is equal to 0, so you just plug in what you know. For Lm, it equals 0.131 cosine, in this case, times 1.948. And that gives the value of 230 feet. For L final, we were to plug in 1 plus 1.1 cosine theta times the time for that final position that we just calculated, and that is going to equal 255 feet. It makes sense that the middle time is smaller than the final time. If that's backwards, you know you've done something wrong. So in this case, we were able to find the x values starting from the y values of position. And the biggest thing to remember from this video is that you need to look for the problem statement saying whether or not it has the values for the velocity equaling 0, and that you have an equation of v with respect to t, v with respect to y, and y with respect to t. Then we also were able to derive x with respect to t. It's really important to distinguish between these two because you actually have two equations from the same starting point, v equals, but in different terms.